Okay, in this video I'm returning once more to the smoke map, or injection quantity limited by map, manifold absolute pressure. If you watched the previous video on this, you'll know that that was our original map. That was the calculator I was using to change the map, and this over here is the new map. Now what I've done underneath here, just here, is use the same information, but I've changed it to air-fuel ratio. So there's the original map expressed as an air-fuel ratio, and here's the modified map, so that one over there, expressed as an air-fuel ratio. And you can see that what's happened is that that expressed as an air-fuel ratio is a drop, because there's the figures that they were originally, and here's the new figures with more fuel. So in other words, the air-fuel ratio has reduced, which is why it's turned blue. Had this increased, it would be red, but it's dropped. Now, in a lot of these areas, the drop is not that significant, and these figures are not too bad, but you can see that you'd be pushing your luck really with these figures here, where they're dropping down below 15. That's getting awfully close to the point at which you're expecting perfect burn, but in life you don't get the same results you might in a laboratory, so you're asking an awful lot to expect to be able to get near to 14.6 in real life in your car, which is why so many people use 16 and I often use 18. So these figures, they're definitely looking a little bit too low in areas, which is why when I was looking at this map originally, I said that we need to go and look at the boost maps to see what available air will be, because this figure here is probably not large enough. So having looked at this on the first video about this smoke limiter, I then went on to boost and boost limiter and single value boost limit. And so now I'm coming back with the information that I got from boost. In other words, when I looked at boost up here, I decided that these were the sorts of figures that I needed to consider. I needed to consider the possibility of 65 milligrams and boost values of somewhere up around 2,300. 2,224, so higher boost figures. And so now I've come back, and what I'm doing is I'm looking at the possibility of using that information to change the axis, because if I don't change the axis, then these values here, as we can see, are sitting in the wrong spot effectively, because I've got quite a lot of fuel, not enough air. So this is my problem. I could either change all of these, in which case I will lose performance, or I need to do something about the available air. Now I've been and looked at what I can do with available air, and of course what I can do is I can up the available air to 2,400, 2,500, that sort of thing. So what I've done is, having looked at the available air and looked at what I might do with the available air by increasing it through boost, I've come back to this point and I've said to myself, well, okay, if I use that information that I've got from my boost, what sort of values will I get here? So what I'm doing now is I'm looking at was these values without increasing this axis, and then here I'm changing these values, so I've changed the axis. And if I change it back to, if you watch these figures here, if I change it back to the original, that was 2000, you'll see that these figures now, this column is the same as that column there. So in other words, this column is giving me the figures that 2000 was giving me. So what I've done is I've moved everything a little bit, because if you look, 1, 2, 3, 4, 5, fifth column across, 1200, 1, 2, 3, 4, 5, fifth column across 1100. So I've moved that 1200 across to here, so I've moved it one to the left, and then I've moved 1300 one to the left, 1400 one to the left, 1500 one to the left, 1600 one to the left, and so on. So you can see what I've done. I've moved all of these one to the left, which left me an empty space at the end. So in other words, that 2000 moved to there, and that left me an empty space at the end. And judging by what I've done with the boost maps, what I could do is I could put in there anywhere around 2300, 2400. But out of interest, I just put 2200, enter, and looked at what it did to the figures. And the figures didn't look too bad. When I looked at the figures, I thought to myself, well, okay, up here I've got 19 to 1, and here I've got almost 16 to 1. So 2200 there doesn't look too bad. So what I would do at this point is either consider making these higher again to match my boost values, or I would consider trying them out as they were. Now, if you want to keep everything in line, in other words, you want these figures to match with your boost figures at the same time, which is often a good idea, then it might be an idea to increase these further, just to pull them up nearer to the figures that are going to be on the boost map. But I would be very tempted to try this as it is, because these figures for the smoke map should be reasonably okay to use, and given that the torque map is probably going to pull us down anyway, we'll probably be okay at this point. Once we've got to this point, then what we've got now then is a smoke map that's been changed in this region. There's the changes for there, so it's been changed in this region, but now these values here, if I just quickly copy those, they would be my new values for there, wouldn't they? So those would go into there, and I would put those in there, and then this would be my new map. So this would be what I would try, and if I wasn't happy with that, I would consider possibly upping these a little bit more, maybe taking one of these out, moving things across again, and adding perhaps another column on the end of perhaps 2400 at the end there, and then seeing if that made any difference. So I'd have a little bit of leeway to play around with that, but I'd certainly consider trying it like this in the first place. Right, now that's pretty much everything covered, but thanks to the fact that this file has got lambda maps in it, it would make sense for me to look at lambda maps next, because they may well be tied in with the fueling on this file. So I will look at those next. So I'll stop there.